Alright, so you guys remember when we did all that stuff about converse and contrapositive and negation? I can't even remember the fourth one. This is when it comes in use. So we're going to look at the converse of the Pythagorean theorem. So whatever the Pythagorean theorem was, which was basically a squared plus b squared equals c squared. Let's look at the formal definition. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. The converse of that is you just take that and you flip it around. If the square of the length of one side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Okay, lots of fancy language for a simple concept. Okay, so what I want to do, I have three numbers here. I've given two legs and a hypotenuse. If 84 squared plus 13 squared equals 85 squared, then you have a right triangle. If not, then you don't have a right triangle. And this is not a right angle. So let's go ahead and try that. I'm going to do 84 squared plus 13 squared. Does that equal 85 squared? So let's go ahead and plug those numbers in. 84 squared is 7,056. 13 squared is 169. So that's equal to 7,225. I'll take the square root of that. And we are correct. Okay, so it is a right triangle because the Pythagorean theorem worked. We'll do another example. A triangle has side lengths 16, 48, and 50. Is it a right triangle? Okay, well if I square these two sides and then add them together, then that number should be the square of 50. So let's go ahead and try that. 16 squared plus 48 squared. Does that equal 50 squared? 16 squared is 256. 48 squared is 2304. So we'll add those two together. That's 2560. Take the square root of that. That equals 50.59. So this is not a right triangle. It is not a right triangle because the sum of the squares of each side did not add up to the square of the hypotenuse. Okay, let's look at the next theorem here. It says that suppose a triangle has sides of length A, B, and C, where C is the length of the longest side. If C squared is greater than A squared plus B squared, the converse of the Pythagorean theorem leads to the conclusion that the angle opposite side C must have a measure greater than 90. In other words, it's obtuse. Thus, the triangle is obtuse. Similarly, if C squared is less than A squared plus B squared, the triangle is acute. These observations are summarized in the theorems below. So if C squared is greater than A squared plus B squared, then the triangle is obtuse. And if C squared is less than A squared plus B squared, then the triangle is acute. So let's go ahead and classify triangles as acute, obtuse, or right. The lengths of the sides of a triangle are given, classified as acute, obtuse, or right. So here's my two legs and the hypotenuse. The hypotenuse is easily recognized as the longest side. So I'm going to do 6 squared plus 11 squared. That'd be 36 plus 121. So does that equal 14 squared? Okay, well 36 plus 121 equals 157. 157 squared, or sorry, the square root of 157 is 12.52, which is less than 14. So then we can use this theorem here, c squared, in this case was 12.52, is less than, oops, I'm doing it backwards. C squared, so c squared here, in this case, 14 squared is 196. 196 is greater than 36 plus 121. That was 157. So the triangle is obtuse. Let's try that again so I don't confuse you guys. I'm going to do 12 squared plus 13 squared. I'll add those two numbers up together. 144 plus 169 is 313. Then I'll do 15 squared, which is 225. 313 is greater than 225, so I can use this one here, a squared plus b squared. This was a squared, that was b squared. They ended up being greater than c squared. So this triangle is acute. And that is it. Alright. Have fun with that one. Let me know if you have any questions.